You are told that the endpoints of FG are F at -1, 2 and G at 1, 2. I want you to reflect, sorry that was a slight typo, the segment in the line y equals x. Graph the segment and its image. You can try this on your own first. If you're going to do that, pause the video and then resume when you're ready to check your solution. First things first, I want to plot my points. I get F at -1, 2 and G at 1, 2. There's my line segment. I'm told to reflect this in the line of symmetry of y equals x. Y equals x is a diagonal line that has a slope of 1. And this is our line of symmetry. Okay. We want to reflect it. So what happens is our point F gets moved directly across to this point over here. The point G also gets moved directly across. We get G prime and F prime. And there are our new points. You know, G prime is now 2, 1. F prime is now 2, -1, where originally F was -1, 2, and G was 1, 2. Notice what happened here. With G, the x and y coordinates were flipped. Same thing happened with F. What was originally x became y, and what was y became x. This is a pattern actually that always happens when we flip across the y equals x line. Let's look at these patterns in general. So we have reflections across common lines of symmetry. You need to know this table. What we find is that if we are reflecting, and let's add a little bit more space here to see this. If we have a shape and we're reflecting across, let's look at the x-axis first. So our reflection is going down here. What happens is all of our x coordinates stay the same. So x coordinates are the same, but our y coordinates change our sign, so we use negative y coordinates. This means that if our original point is AB, then the image point is A, negative B. And that reflects us across the x-axis. Alright, let's now look at what happens when we reflect across the y-axis. If I want to reflect this shape across the y-axis, all of my y values stay the same. Each point has the same height, but the distance, the horizontal distance, changes signs. So y coordinate stays the same, but we use the negative x coordinate. Meaning, if our original point is AB, then the image point is negative A, comma B. Okay, next. We already saw kind of what happens when we reflect across the line y equals x. We saw that above. What happens with all of our ordered pairs is the x and y switch spots. So if the original point is A, comma B, then this means that my image point is B, comma A. And then lastly, I can also look and see what happens when I reflect across. There we go. The y equals negative x line.